Hello class, and welcome to the COMP-111 study guide review recording. All right, so test 2 is your final exam for this course. It's going to follow a similar format to what you found for test 1. The test is comprehensive, meaning that it's going to cover the entire course. However, the focus of the course will be on weeks 7 through 12. The reality for that is that when we're programming, we can't not use components. Like we can't not define variables or not use assignment statements or condition statements, right? We continue to build on things as the course goes using each of those constructs. And the same goes true with the exam. We can't not use the components from the beginning of the course, so you're going to need to be familiar with those for the final exam as well. So definitely when you're preparing for the exam, you'll want to focus on the readings and key points from weeks 7 through 12, but you're going to want to go back and review the information for the first 6 weeks as well, and definitely reviewing the study guide for test 1 would also be beneficial. The exam format at the time of this recording is paper and pencil, no book, no notes. Definitely check with your instructor to see if that has changed. It will contain true-false questions, multiple choice questions, and then short answer and coding questions. Now for this final exam, there will be a greater number of short answer and coding questions than what you found on the first exam. So you can anticipate that you'll be required to do more of the short answer and coding. All right, so I'm going to focus this study guide recording on 12. You can go back and review the recording for test 1 to see what was emphasized for weeks 1 through 6. All right, so chapter 6. Chapter 6 was all about loops, and in the loops we identified 4 types of loops, right? We had our while loop, the do while loop, the for loop, and then the enhanced for loop. And in those loops, we used sentinel values. So you want to make sure that you're comfortable not only with the 4 types of loops, but also with the sentinel value. We talked about the benefits or what the purpose of each loop was for, right? We talked about condition controlled, which means it will continue to execute as long as a certain condition equates to true. So that was your while loop and your do while loop. Okay, we talked about count controlled, where it's going to execute a specific number of times. So that's going to be your for loop and your enhanced for loop, because the enhanced for loop is used to iterate through an array or an array list, so it's a specific number of times. We also talked about being a pre-test or a post-test loop. If it's pre-test, meaning that it checks the condition first, and if the condition equates to true, then it executes the loop. A post-test meaning that the loop executes at least one time and then checks the condition and continues to execute as long as the condition remains true. We also talked about when each loop could be used. So your while loop, your for loop, and your enhanced loop could execute 0 to many times. It could execute 0 times because they're all 3 pre-test loops. So the condition may be false right at the start and never execute at all, right? Where your post-test loop, which is your do while, is going to execute at least 1 time, so it can execute 1 to many times. There are 4 parts to every loop. So you have setting your condition variable, checking your condition, the body or the statements that you want to execute as part of the loop, and then providing a means to change your condition. So you want to make sure that you're familiar with the loops, the 4 different types of loops, you're familiar with the 4 different components of the loop, that you're able to identify which loop to use in which situation, that you're comfortable writing each of the 4 different kinds of loops, and that you're comfortable using a sentinel value in providing a way to stop a loop for the while loop or the do while loop. And so here we have some different practices. We also ask what loop can be rewritten as a while loop or as a do while loop, or can a for loop, be rewritten as a while loop or as a do while loop. So you want to look at those and go, can I do that? Is that possible? All right, and then we have some different situations here. Write a loop to process an array of data type strings, so to print out each value in this array, and then rewrite it as a for loop, rewrite it as an enhanced for loop, write code to prompt the user for entry of a value, accumulate a total as part of the loop, and then stop when you set no value. We also have some code up here where you need to evaluate a loop and determine how many times is it going to execute and what the output is going to be. And then down here, random numbers. So the random number generator was also introduced as part of Chapter 6. So this will allow us to randomly generate a number. However, you do need to import the class. So it's a utility class and it needs to be imported in order to be able to be used. And then you need to create your random object. And from the object, then you can call one of two methods. So we had the next double and we had the next integer. Remember, the next double will generate numbers from you from -1 to +1, so it's going to generate fractions, versus the next integer will generate whole numbers for you from 0 up to the number you specify exclusive. So here we see a value of 10 is going to generate from 0 to 9. And so you really have to think about, like, what if I want random numbers from a value of 1 to 200 inclusive on either side, so I could include 100 or I could include 200 and anything in between, then how am I going to do, like, what manipulation do I need to do when I call the random number generator to generate those types of numbers? And so we have a statement here and you're asked what are the possible values. And then here you're asked to generate a random number that represents the roll of a dice. So you want to be comfortable using the random number generator to generate different numbers. Chapter 7 was all about arrays, array lists, and we also talked about wrapper classes and auto boxing and auto unboxing. You want to make sure that you're comfortable identifying all of the wrapper classes for our primitive data that we've been using in the class, and that you're able to call the different methods from the wrapper classes to convert integer to string and vice versa, double to string and vice versa. Okay. When it comes to arrays and array lists, you want to make sure that you are very comfortable declaring an array or an array list, that you are comfortable manipulating the elements in both an array and an array list. So you know how to change the value of an element in an array or array list, how to remove an element, how to add an element, all of those sorts of things, so that you're able to manipulate the values of the elements in both an array and array list. You also want to make sure that you are very comfortable identifying the boundaries of both an array and array list. So what's the lower boundary? What's the upper boundary based upon the code that you're provided? You need to be able to identify the advantages and disadvantages of both an array and array list. Now, it's very tempting, especially in this course when you're just being introduced to these constructs, to think that the array list has all of the benefits and the array does not. But that is just not the case. There are definitely times when it's better to use an array than it is to use an array list. And there are some definite advantages to an array as well over an array list. So you want to make sure that you can list, what are the advantages of an array versus an array list? What are the disadvantages? What are the limitations of an array? What are the limitations of an array list? And they both have pros and cons associated with them. Okay, an array list is a special type of class. So what type of class is that? What are the methods available with an array list? You want to definitely make sure that you can identify the different methods and use those methods. You will undoubtedly be asked to write code to manipulate either an array or an array list, and so you're going to definitely need to be able to write code to add values, set value, change values. So you want to make sure that you're comfortable not only naming the methods but also using the methods in an array list. Here we've given you a bunch of different declare statements so you can practice declaring arrays versus an array lists. And then down here you're asked, how do you return the length of a string, an array, and an array list? These, we have one that's a length method, one that's a length attribute, and one that's a size method. So which is which, and how do you go about that? Now, for an array, Just because an array has a length of 30 doesn't mean that all the elements in the array are populated. Remember, we need to define an array to encompass the maximum number of elements that we think are possible, but it doesn't mean that we're always going to use all of those elements. So how can you tell, like what strategies are there for you to determine which elements in an array have been populated and which have not? Okay. And then here's some different code, to populate an array list. So how would you go about doing that? The purpose of the enhanced for loop, and how would you go about using that? And then two-dimensional array. How would you go about defining a two-dimensional array? And then also, how would you go about manipulating or accessing the elements of a two-dimensional array, which definitely involves a nested if statement. So how would you go about doing that? All right, so that brings us to Chapter 8. Chapter 8 was all about identifying classes, identifying methods. So, what is an actor class, a library class, a utility class? What does it mean? What is cohesion versus coupling? And do we want high cohesion, low cohesion, high coupling, low coupling? Like, what is our goal with regards to those? We have a package. So what is a package? When we're designing a package, or do we want high or low coupling? Okay. When you're viewing a UML diagram, what classes are dependent upon other classes? So as you're evaluating a UML diagram, how do you know what's dependent? And what does that mean if they're dependent? Immutable versus mutable classes, side effects, preconditions, postconditions. You want to be able to define and identify all of those components. A JUnit assert method, is that testing a precondition or a postcondition? Static, what's a static method? What's a static variable? Do they accept implicit parameters? Do they belong to the class or to the object? Local variables, when does a local variable cease to exist? Can a local variable have the same name as an instance variable? Really, scope is what we're talking about here. We're really talking about scope. So how do we identify the scope of an instance variable versus a local variable defined to a method versus a local variable defined in a while statement or defined in an if statement? Like, really, what's the scope of that particular variable? Here you're given some code where you're asked to identify the local variables. Here you're given a piece of code where you have an instance variable and an explicit parameter that both have the same name. So when I set zip code equal to 43215, which one is it? Am I setting the explicit parameter equal to this, or am I setting the instance variable equal to this? Okay. And then we have some other code where we have the variable temp used over and over again. Here it's an instance variable, here it's a local variable, here it's an explicit parameter. And so we're asking in each one of these cases, is this legal? Is it legal? Meaning, will it compile? So if we were to look at this, you need to be able to identify the scope of your variables and then determine, will it compile, will it not compile? Have I violated something in the Java language? All right, Chapter 12. If you're given a task description such as, a pet store, so you've got a pet store and you need to identify, and they give you all this information, what do the nouns in that task description represent? What do the verbs represent? When you're viewing the task description, what classes should be created? Like what things come out to you as this should be a class? And if you're thinking of that class, what instance variables would be needed, what methods would be needed? And then draw a dependency diagram for this description. If you've identified 4 or 5 classes, how do they relate to each other? What's the dependency in the classes? And then Chapter 14, we did sorting algorithms and then binary searches. So what is a sorting algorithm, and how do all the different algorithms that we introduced work? Insertion, bubble, merge, and selection sort. How do each one of these sorting algorithms work? And what are the 2 ways in which complexity is usually measured in computer science? And the binary search also. How does the binary search work as well? All right. So these are all the different topics that you could expect to be addressed on the second exam here. Definitely go through this study guide, complete each one of these things. This would really provide you good stead in preparation for the exam. All right. Go through, answer all the questions. If you're not sure, certainly email your instructor and ask about it. And you may even ask your instructor if you're able to submit them a completed copy of this study guide 2 or 3 days in advance of when you plan to take the exam, certainly. But if you could submit them, perhaps they'll review it for you and let you know areas that you need to spend a little extra time on. All right, so that's it as far as the study guide goes for test 2. Certainly if you have any questions, please do not hesitate to ask your instructor.